matrix multiplication. So I have a 3 by 3 matrix, 3 rows by 3 columns, and I'm multiplying that by 3 rows, 2 columns. So since the number of columns in the first matrix is the same as the number of rows in the second, we can do the multiplication, and we end up with 3 rows, 2 columns in the answer. So we start out row 1, column 1. So I'm using row 1 in the first matrix and column 1 in the second matrix. And I match them up. 3 times negative 1 is negative 3. 2 times 0 is 0. And 1 times 3 is 3. And I add the results to get 0. Now I take still the first row, but now the second column. 0, 2, 0. 3 times 0 is 0. 2 times 2 is 4. 1 times 0 is 0. So adding the result is 4. Now I change to the second row in the first matrix. Negative 1, 0, 2. And I'm multiplying it by the first column in the second matrix. Negative 1 times negative 1 is 1. 1 times 0 is 0. 2 times 3 is 6. Adding, I get a result of 7. Now I'm going to take the second column, negative 1 times 0 is 0. 0 times 2 is 0. 2 times 0 is 0. Add those results. Now I want to take the third row of the first matrix and the first column in the second matrix. 0 times negative 1 is 0. Negative 1 times 0 is 0. 2 times 3 is 6. And then I want to finally move to the last column in the second matrix. 0 times 0 is 0. Negative 1 times 2 is negative 2. 2 times 0 is 0. Adding to get negative 2. And that's matrix multiplication. This is the minimum number of searchers. And this is a fan, an F5, 5 vertices. Now, this is an optional topic, so it is not included in the online course. So we're looking for the minimum number of searchers necessary for this problem. So if I start with one searcher here, and then I leave it fixed there, and I take a second searcher that's going to go around the outside. That's searcher 2. The third searcher is going to come down, go across, and go back up. So the minimum number of searchers that I need for a fan is 3. Binomial theorem. So because it's the third power, there are 4 parts that we need here. Combination 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. Then there's also the first term in the expansion. You start at the highest power, x to the third, x to the second, x to the first, and x to the 0, which is 1. Then I have y squared to the 0, which is 1. Then y squared to the first. Then y squared to the second. And y squared to the third. Combination. The combination of 3 choose 0 is 3 factorial over the difference, which is 3 factorial, times 0 factorial. 0 factorial is 1. So 3 choose 0 is 1, and 3 choose 3 is 1. And x cubed times 1, the first term is x cubed. Then 3 choose 1 is 3 factorial over the difference, which is 2 factorial, times 1 factorial. So it would be equal to 3 4, 3, choose 1, and 3, choose 2. And then we have a plus 3x squared, y squared. And then we have 3x and a power raised to a power. We multiply the exponents to get y to the 4th. 1 times 1 is 1. We multiply the exponents to get y to the 6th.